Now this one says use the graph of the function to solve the inequality. So we're going to do the same thing with this one like we did in the last video. This one is a little more complex, so we'll get into the gist of all of that as we go through it. The idea is the same though. Again, if my f of x is less than or equal to 0, that means I'm looking where my y value is negative or equal to 0. So my y value is measured by the y-axis, and where my y is negative is down here. So wherever my function is below the x-axis is where is the values I'm actually looking for. And again, we talk about these intervals in terms of x, even though we're measuring y values here. So keep that in mind. So I'm going to look at this, and here's a 0 here. And I see to the left of that 0 that it drops below the x-axis. So that tells me that that's where it's going to be less than 0 at. And right on that value here is where it's going to be equal to 0. So I'm going to include that because it says equal down here. And then it's going to go straight to the left here. So that's going to be one interval I'm going to include. And that interval is, so that interval is going to be negative infinity to negative 3. And again, I include it because of the equal sign. So I can actually write that over here. Negative infinity to negative 3. Terrible looking 3. Including the 3 union. And then I also have this piece here. And remember, we always represent our intervals using x values. Okay, so now it looks like it hits here at that point, and it looks like it goes all the way to, it looks like there's an asymptote here. And that looks like it's at negative 2. So that's going to be, and it can't include the negative 2 because it's an asymptote there. So again, it's the x values that we're talking about here, but we're measuring the y values. So that's going to be negative 2 to 0. And we can include the 0 because that is included here because of the equal sign. Okay, so now the last part then, actually, yeah, there's one more part here. And I see that I have another asymptote probably here, and that looks like it's at 4, x equals 4. So this is going to go from 0 to 4. It includes the 0. Or, yeah. No, not 0. I'm sorry. Not 0 to 4. I messed up there. It's actually this number here because this part is above. Okay, so be careful. That looks like it starts at 2 and goes to 4. And I can include the 2. So 2 to 4. Not including the 4 because that looks like an asymptote there. And that will be everywhere where my function is less than or equal to 0. Now let's take a look at the f of x greater than 0. All right, so I'll get rid of all this other stuff here, and then we can talk about that one. All right, so now we're going greater than 0. So again, I still have these values here that are intersecting my pieces. And also I have these asymptotes. Don't forget about those because I can't have those in my domain. And like I said, we are using x values to describe greater than the y values being greater than 0 here. So it's like we're taking those strips in a way. I'm taking that whole strip, and that strip is parameterized by x's. Okay, so anyways, so there, this one is negative 2. I'll just write x equals negative 2, just so you know. And this one looks like it's x equals 4. Just so when we go back to it, it makes sense why we picked what we picked. Okay, so now we're greater than 0. So it looks like it starts at negative 3 here. Oops, bad 3. I'm terrible with 3s. That's like my worst number. And I include the 3 because that's my 0 there. So negative 3. And it looks like I'm going to go to negative 2. And I can't include the negative 2 because it's an asymptote. All right, and then I have this little spot in the middle here from 0 to 2. So that's going to be, and it includes both of those because they're both in my domain. So 0 to 2. And then I have another interval, which is this piece here. That's all greater than 0, too. That means above the x-axis. So that's going to be from 4, because that's where my asymptote's at. And I'm not including the 4 because it's an asymptote. And I'm going to go to infinity. And I always use parentheses with infinity. So there we go. All right, so now looking at part C here, I want to look at this more algebraically. So here's our actual function of the graph. And I just kind of wanted to show you the graph and also it algebraically. So let's take a look at what that factors into. So if I factored, it factors into this. Now, again, take your time, remember how to factor and whatnot. So now all I'm going to do is the same idea here. Now what's a little different here is I want all asymptotes, vertical asymptotes, and all zeros for this thing. I should say y-intercepts. And where the top is 0, those are my y-intercepts because nothing cancels here. And where the bottom is 0, those are all my vertical asymptotes. All right, so we're going to label all of those. And I'll talk about them as I go through them here. Okay, so first things first, I'm going to do my y-intercepts. So that's where my top is 0. So I got one at 0 here, and then I also have one at 2. And then I also have one at -3. And remember, all I'm doing is plugging in numbers here that make it 0. So this would be a 2. That would be a -3. And you can see how I'm going to get 0 for those. And then 0 here. I did all my y-intercepts first. Now I'm going to do all my vertical asymptotes. That means I'm looking where the bottom is 0 now. Because they could change there as well. So that's going to be at, and I'll use a different color for those. So for these two, I'll use purple. So that's going to be at -2 and +4. And now I'm going to use, let's see, what color should I use for the test points? I'm going to use the green again for the test points. Okay, so I'm going to have to pick a point here, which is I can pick -4. I can pick here, -2.5. Now keep in mind, I don't care about exact numbers here. I just care about signs. And then I can pick -1. I can pick 1. I can pick 3. And I have to pick on the other side of this too. So I'm going to pick 5. So those are going to be all the values I'm going to have to test for this, for either positive or negative. So it's going to take a little bit of time for us to get all these. So when I plug in -4 for everything, that's going to be a negative. That's going to be a negative, and that's going to be a negative. And then on the bottom here, that's going to be a negative, and that's going to be a negative. They're all negatives, but notice I have an odd number of negatives here. So those two together are going to make a positive. Those two together are going to make a positive when I times them. And then I'm dividing here, and dividing is like timesing when I talk about signs. So that tells me there that I'm going to end up with a negative. And that's one thing you can do in this process too, is just count the number of negatives. If it's odd, it's negative. If it's even, it's positive. And that's a nice way to look at that as well. Okay, so again, we know that this is going to be negative. Okay, now let's do the 2.5. -2.5. That's going to be negative, and that's going to be negative, and that's going to be, that 2.5 is less than 3, so that's positive. And that 2.5 is going to be bigger than 2. Negative, so it's going to be negative, and that's going to be negative because negative plus a -4 is negative. Okay, so that's going to be 4 negatives, so that means it's going to be positive there. Because remember, now we can think about it in terms of just odd number of negatives is negative, even number of negatives is positive. So then for the next one, the -1, so that's going to be negative, that's going to be negative, that's going to be positive. That's going to be positive, and that's going to be negative. So I have an odd number, so that means this here is going to be negative. Now let's try 1. So positive, negative, positive, positive, negative. So I have an even number, so it's positive. Now let's try the 3 here. Okay, so that's going to be positive, 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 and negative. So I have odd number of negatives, it's negative. Now the last one here is 5. So positive, 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 and positive. So it's positive. Oops, this negative. Oh, that's positive for the... Just want to get it out of my way of my number line. I don't want to get anything mixed up here. So this is our setup for this one now. So again, if I just factored it without graphing it, because graphing does take a lot of time to graph it, and sometimes just this nice number line really sets everything up nicely for me. And now I can easily see intervals. Like if I was doing f of x less than or equal to 0, then I would be able to say, hey, now remember the red and the green, the red and the purple are my actual values that I'm taking the intervals of. The green is just the test points. So that means then, when I look at this, if I'm looking where I'm negative, and that's what this is saying here, or equal to, now that's where I got to keep straight the asymptotes. So then I could say this is good for my negative. And then also, not including that one, but I can include the 0. That would be good, and that would be my other interval. And then for the last one here, the red is good, but the asymptote is bad. There. And that's where I'm negative. So I can see those 3 intervals, and I could just map them and see that I got exactly that. So that's just one of them. So now you can see how to do these algebraically where it's not too bad to truly understand that. So there's my answers. And again, the last one was just for understanding when they say in the homework, solve algebraically. It's still analysis that I'm using here to do that.